In this video, we will be using knowledge of the families of special right triangles to find missing sides. So you can see here, find each missing side length. First thing, we have a list of Pythagorean triples over here, and also 30, 60, 90, and 45, 45, 90, and then how to get sides from each of those. So coming up here, you'll notice that we have 6.5 and 6. So first we need to figure out what family we're in. When the sides are not integers, it makes it a little bit harder, but let's make them integers. So let's multiply by 2, and we'll get 13. Let's multiply by 2 down here, and we get 12. And then this would make this a 5 over here. And you'll notice the triangle family is in parentheses, but each of the actual sides is divided by 2. So this side will be 2.5. Now we will come over to here. As before, we will multiply by 2 to get integers. So we have 45, and down here we have 24. So now let's look over here, and we notice that 8 times 3 is 24, which is what we have here. And then 15 times 3 is 45, which we have here. And then 17 times 3 is 51. So you'll notice here we're not putting the reduced family on the diagram, but the multiple. So since this is 45 over 2, and this is 24 over 2, this side is 51 over 2. Now coming to here, it gets much easier because this is 7 root 2, and that's 25 root 2. 7, 24, 25 is the family. So this is 24 root 2. Coming down here, we can see that we have a 30-degree angle, a 90, and then that has to be 60. So we have a 30, 60, 90. And first thing we're going to do is go from the mid side to the small side. And then we come over here and we realize going from the mid side to the small side, we would divide by root 3. So then this side is 7. And then again, coming over here, going from the small side to the hypotenuse is times 2. And that gives us a side length of 14. From there, we come over to here. And again, we have a decimal. So let's multiply by 2. And we get 40. Let's multiply this by 2 and we get 9. So 9, 40, 41. So the 9, 40, 41 is the family, and the side is 41 over 2. You could also say it's 20.5. Either one is fine. Now coming down here to this triangle, we have 8 and 10, and you'll notice that 4 times 2 is 8, and then 5 times 2 is 10. So then this is a 3, 4, 5 family of triangles, and then 3 times 2 is 6. Now coming over to this triangle, you can see we have a right triangle, and we have 2 congruent sides. So this is a 45, 45, 90 triangle. Now, if it had told us that we had 2 congruent angles, that would give us the same information in the end. If angles, then sides. If sides, then angles. And we come up to here, and we see that to go from the legs of a 45, 45, 90 to the hypotenuse or back involves a factor of root 2. We're going from the longer hypotenuse to the shorter leg, so it's going to be divided by root 2. So this will be 7 over root 2, and this will be 7 over root 2. Now note on this, your teacher might want you to rationalize the denominator, and that will get us 7 root 2 over 2. Either one of these forms is fine. It just depends on how you need to present it. Now coming to this one, again, let's multiply by 2. So 2.5 times 2 is 5. 2 times 2 is 4. And then that makes this a 3, 4, 5 family of triangles. And it's all divided by 2, so this side is 1.5. Last triangle, we have 13 root 3, and we have a 30 and a 90, so that's a 60. So this is a 30, 60, 90. Now remember again that going from the hypotenuse of a 30, 60, 90 triangle to the short side, you divide by 2. So this will be 13 over 2 root 3. And then going from the short side to the mid side of a 30, 60, 90, you multiply by root 3. So that is going to be 13 over 2 root 3 times root 3. So then this will be 13 times 3 over 2, which will be 39 over 2. These problems were a bit trickier because sometimes you multiply and sometimes you divide, and dividing is a bit harder. But as always, just do the problem 2 or 3 times, make sure you've got it, conquer it, and then move on.